Okay, so on to look at an example here. First of all, we have Nicole on the top left of the screen, and Nicole has a public key and a private key. She gives the public key to everybody and keeps the private key private. So on the left-hand side of Nicole, we have Nicole's private key, and on the right-hand side, we have the public key. So that public key is distributed to everybody across the network. Anyone can use the public key to encrypt the data, but only Nicole will be able to decrypt it because she is the only one who has access to her private key. Again, linked via mathematical formula to the public key, but not the same as the public key. Caleb decides that he would like to send a private message to Nicole, and he can do this by encrypting the message using her public key. So the same public key that everybody has is used to encrypt the message. Nicole, however, is the only one who can decrypt the message because she's the only one who has the private key. Now, Jamie comes in and Jamie decides that he would like to pretend to be Caleb. He has the same public key that Caleb has because it's the same public key that everybody has. It's Nicole's public key. When Nicole gets the message from Jamie, she's no way of knowing that it's not actually from Caleb because it was encrypted using the same public key. So to combat that, what we have is we have Caleb generating some keys. So Caleb creates his own public and private keys. He keeps the private key private and he makes the public key public. So everybody gets a copy of Caleb's public key and he keeps his private key. If it wasn't complicated before, it is now. Caleb has a public key, which is Nicole's public key, and he has a private key, which is his own private key. Now that private key is used to encrypt data, and he's the only one that's able to encrypt data in that way, but everybody can decrypt it. Before sending a message, Caleb calculates a hash value, and that hash value is based on the data that has to be sent. He then uses his private key to encrypt the hash value. Then he adds this to the message, and he uses Nicole's public key to encrypt the overall message. Nicole is the only one who can decrypt the message because she's the only one that has her private key. Everybody has the public key, but she's the only one that has the private key. She then uses Caleb's public key to decrypt the signature. She checks the message hasn't been compromised using the hash value. Now, Jamie can encrypt a message, but it won't have Caleb's signature on it. And Jamie could, in theory, decrypt Caleb's signature using Caleb's public key, but it's encrypted using Nicole's key. So this method enables secure communication between Caleb and Nicole using a set of public and private keys. Nicole's public and private key and Caleb's public and private key being used in slightly different ways. Even though Jamie has two keys, they're both public keys. The one from Nicole is Nicole's public key that enables him to encrypt data, and the one from Caleb is Caleb's public key that enables Jamie to decrypt data. But when he receives the data communication from Caleb, he can't decrypt it using Caleb's key because it has been encrypted using Nicole's key already.